This is a follow-up video talking about functions. We're going to add a function to our pipe object from the previous video. Functions are great for helping repetitive calculations that are similar. You'll see what I mean here, hopefully. Here's a short example. So from the previous example, this is where we left off. Now we're going to add a function to the pipe to be able to calculate the pressure drop through the flow or through the pipe as it flows down the length of the pipe. So I'm going to first run my first cell, and I'm going to add in a comment about defining the pressure drop. Here's my function definition. Functions start with the DEF, and then I name it pressure drop. I bring in the self. Whenever you have a function inside of an object or class definition, you refer to self to bring all the properties of the object into the function. And we're going to define a cross-sectional area, as the pressure drop does depend inversely, is inversely proportional to the cross-sectional area. So I got the self, it's the diameter of the pipe there, and squared multiplied by pi over 4, as you all are familiar with. Major losses refer to the flow down the length of the pipe, and it's a function of the viscosity and length. Here is just an estimate. It's a little more complex, that Darcy-Warbach equation, but here's just an estimate. The fluid viscosity, as the thickness of the fluid increases, you have to push harder to get it down the length of the pipe. And the length, as the length increases, the pressure drop increases. So there's our estimate for our major losses. Our minor losses refer to like elbows and turns and valves and so forth. Here's also just an estimate factor. And then our total pressure drop is going to be our major losses plus our minor losses. That's now part of our class. Here's the pipe definitions. We made a list of pipes, and our 0th item pipe is just this first one, pipe 1. And I can refer to my pressure drop here and just have it calculate that, and it returns the pressure drop down the length of the pipe. So what if I want to do that for all of the pipes? So I'm going to create a function to create to calculate the total pressure drop through those 3 pipes, and I'm going to initialize a total or a counter, and then for each of the pipes, so it's going to loop through each one of these pipes and calculate the total pressure drop. So just like I calculated the pressure drop for one of those, here's I'm doing the same thing and then adding it to the total. When the first time it's total is 0, and then the second time it's from the pressure drop this value, and then so on and so forth. It adds up all those pressure drops, and then I'm going to return the total. And so I can run that and then give it a total pressure drop, and there's my total pressure drop. Hope that's helpful.